Laws of motion, circular motion, gravitation, work energy, and linear momentum. About 9 questions here. Let's get straight into the questions. The first one talks about a force of 10 newtons being applied horizontally on an object of mass 5 kilogram. If the coefficient of static friction is 0.30, what is the force of friction on the box? So there is a force of 10 Newton that's being applied, as the diagram shows, and friction is always opposite to the motion or to the intended direction of motion. So we have friction acting in the opposite direction, and the mass of the object is given as 5 kilogram. Now we got to find the force of friction. There's only one formula for force of friction. For static friction, that formula is mu multiplied by n. So here is the free body diagram showing all the forces acting. Along the horizontal, we have the applied force and the force of friction. That's along the horizontal. As we can see, this is the applied force, and force of friction is acting in the opposite direction. And then we have the weight of the object acting down and the normal force. Force of friction, F sub S, is mu S, which is the coefficient of friction, multiplied by the normal force. In this case, we know that the weight of the object is exactly balanced by the normal force, or Fn minus mg is equal to 0, because Fn is in the positive direction and mg is in the negative direction, which makes Fn equal to mg. So substitute back the value of Fn as m times g, and then calculate the force of static friction. Mu is given as 0.30, so multiply that with 5, which is the mass, times 9.8, and that would give us the force of static friction. When you put those numbers into the calculator, you get 14.7 newtons as the force of static friction. But here is a very important point. Static friction can only be equal to the applied force. So in this case, the applied force is 10 Newton as given in the problem. The static friction is calculated to be 14.7, but friction cannot be 14.7 newtons in this case. It can only be a maximum of the applied force, which is 10 Newton. So although the calculation for static friction gives 14.7 Newton, the actual value of static friction is only 10 Newton. And the reason is, you remember the graph drawn between applied force and static friction? On the x-axis we have applied force, and on the y we have friction. And we see that as the applied force increases, static friction also increases. But static friction can only be equal to the applied force. So like I'm showing here, if the applied force is only 10 Newton, although the maximum static friction could be 14.7, right now, since the applied force is 10 Newton, friction can only be 10 Newton. I hope that's very clear. So in this case, the answer is friction is 10 Newton. Let's move on to the second one. In this case, I just changed the 10 Newton to 20 Newtons. It's the same problem. And I'm trying to show you something here. Remember that in the last case, the maximum value of static friction was only 14.7 newtons, and we are applying 20 newtons. So obviously the object is going to move because the applied force is more than the static friction. The free body diagram will be the same. And we have already calculated static friction to be 14.7 newtons. And I just want to move this faster. Now the applied force 20 newtons is more than static friction. So like I said, the object must move. And when the object moves, it's no longer static friction, but kinetic friction that comes into effect. So in order to work out this problem, you need the coefficient of kinetic friction, which will be given. So assuming that it's 0.25, we calculate the new friction, which is mu sub k times Fn. So 0.25 times 5 times 9.8 will give 12.25 newtons. So in this case, the force of friction is 12.25 newtons. Going ahead, you could be asked to calculate the acceleration here, which case you'll have to find the net force. I'm not writing that, but the net force would be 20 minus 12.25. Right? 20 minus 12.25. And so when you get that net force, you divide it by the mass, you will get the acceleration. Now moving on to the third one. Now I'm handwriting the questions here. So here's an object which is sliding down, and it slides, actually it slides a total of 10 meters, and it's on a horizontal surface before it comes to rest. So the object slides 10 meters on a horizontal surface before coming to rest. And the initial velocity or the initial speed is 5 meters per second. Find the coefficient of friction. So it's very clear that it's the force of friction that stops this object from moving. So first we have to find the force of friction. Now to find the force of friction, you need the coefficient of friction, which is not given. So we will have the force of friction in terms of the coefficient. But let's first find the acceleration of the object from the given quantities and using kinematics. So the initial velocity is 5 meters per second. The final velocity is 0. Displacement is 10 meters, and we're looking for acceleration. The equation that connects them in kinematics is Vf squared is V naught squared plus 2a delta x. When you substitute that, substitute the terms and calculate carefully, you get, of course, you're going to get a as negative because it's really slowing down. And you will get the acceleration to be negative 25 by 20, as you can see here, which gives negative 1.25 meter per second squared. So that's the acceleration. Once we know the acceleration, we can find the net force, because by Newton's second law, net force is mass times acceleration. But there's only one force in this case, which is friction. So the net force is actually kinetic friction, which is given by that formula. And again, like in the last case, the normal force is balanced by the weight, so mu k times mg. So we can find the net force. And that is mass times negative 1.25. Mass of the object is not given. So we'll take that and substitute it here for the net force and set it equal to mu k times mg. Now you can see that the masses do get cancelled from both sides, and we can find out the value of coefficient of friction. Comes out to be 1.25 by 9.8, which is 0.1275, rounded off to 0.13. Remember that coefficient of friction has no units. So that's how you work out this problem. Again, first find the acceleration, then find the net force, and the net force is the force of friction, which gives us the coefficient of friction. Brings us to number 4. So what do we have here? A 50 Newton box is pulled up 5 meters along the surface of a ramp. So now it's an inclined plane. Then the 50 Newton box is being pulled up 5 meters along the surface of a ramp that rises at 40 degrees above the horizontal. How much work is done on the box? Okay. So this is a problem regarding work. And work is force times the displacement along the direction of the force. Force times displacement along the direction of the force. You'll understand that when I draw the diagram. So here's the ramp, and that's the box being pulled up. So that's the applied force, and the angle is 40 degrees. And the other forces are the weight acting vertically down and the normal force acting. And then you have, this question does not talk about friction. So if a question does not talk about friction, you assume that the surfaces are frictionless. All right? So there is no friction, and so the only thing we got to do is we got to break up the weight into its components. Since we have the x-axis along the ramp and the y-axis perpendicular to it, we got to break the weight into those two directions. And this angle is going to be 40 degrees. So this will be mg cosine 40, and this will be mg sine 40. We've done that many times now. So again, make sure that there is no friction here. If there was friction, there would be an additional force shown down the ramp. So now it's clear that in order for the object to move, the applied force has to be equal to mg sine theta. Because if you apply a force less than mg sine theta, it's not going to move up. Okay? So I repeat, the applied force must be equal to mg sine theta. So work is the applied force times the displacement in that direction, which is given as 5 meters. So mass times g is 50 newtons. That's given. 50 newtons is mass times g. Sine 40 times 5 gives you 160.7 joules. And the work done on the box is 160.7 joules. But sometimes you may be asked to find the work done by gravity. Now we're going against gravity, so all you got to do is whatever work we had to do, take the negative of that. Take the negative of that. So the answer for work done by gravity would be the negative of this quantity, which is negative 160.7 joules. Again, why? Because we're going against gravity. All right, so that brings us to the next one. Here is the next question. An object of mass 150 gram is dropped from a height of 10 meters from the ground. So what is its momentum just before it hits the ground? So an object is dropped from a height, and the mass of the object is 150 gram, and it's dropped from a height of 10 meters from the ground. What is its momentum just before hitting the ground? Now, momentum is what? Momentum is mass times velocity. So, if you're asked to find the momentum just before it hits the ground, that means you have to find its velocity just before it hits the ground, for which we can use kinematics. So, that's what we're going to do. We know the initial velocity is 0. We're looking for the final velocity. The acceleration is negative 9.8 meter per second squared. Delta y is negative 10 meter because it's going down. We have this equation. Vf squared is v naught squared plus 2a delta y. Substitute the quantities into that carefully. So, and remember that it's a square on the left side, so got to take the square root after you do that. And then this quantity is 0. That's why you only have 2 times a, which is negative 9.8 times negative 10. So you get 196. The square root of 196 is either plus 14 or minus 14, but this case we'll take negative because we know for sure it's going down. Therefore, the momentum is mass times velocity. And remember to convert the 150 grams into kilograms. So the momentum is 0.15 because the mass has got to be in kilograms times negative 14 actually. So momentum is a vector and should be negative 2.1 kilogram meter per second. So strictly speaking, this is supposed to be negative, okay? So let me just put a negative there because the velocity is negative. You're going to get negative 2.1 kilogram per meter per second. If you're asked to find the magnitude of the momentum, you need not put the negative, which the word magnitude means just the absolute value. All right, I hope that makes sense now, right? So to find the momentum, find the velocity and multiply it with the mass. That takes us to the next one. What do we have here? A bullet of mass 100 gram is fired at 50 meter per second from a pistol of mass 2 kilograms. And so we know that when you fire a bullet from a pistol, the pistol is going to go back. It's going to recoil. Okay, and you're asked to find the recoil velocity of the pistol. This is a specific case of conservation of momentum. And that means the total momentum is conserved. The total momentum before firing is equal to the total momentum after firing. Now, what is the total momentum before firing? What was the bullet doing inside the pistol? Nothing. It was not moving. So the initial momentum of the bullet is 0. And the gun was, the pistol or the gun was held absolutely motionless. And therefore, its initial velocity is also 0, making its initial momentum 0. So both the bullet and the gun initially have momentum 0. All right, so you're going to have initial momentum before firing is equal to the final momentum after. 0 is the initial momentum before firing, like I explained. And after firing, the mass of the bullet in kilograms is 0.1 multiplied by its velocity, which is 50 meter per second, plus the mass of the rifle, 2 kilograms, times its velocity, which we do not know, which we're looking for. So that's the unknown quantity here. So when you solve that equation, this becomes 5, and then you have 2 times velocity, and when you rearrange that and calculate, you're going to get negative 2.5 meter per second. Remember that the recoil velocity of the gun is going to be much smaller than the velocity of the bullet because the mass of the gun is so many times bigger. So that's how you do that. A specific case of conservation of momentum. That's what this is. Brings us to the next one. So here we have a problem that could really be a tough one. So here we have a 340-gram air track cart traveling at 1 meter per second suddenly collides elastically. So that word is important. It's an elastic collision. So it collides with another stationary cart. That means that cart is not moving. What is the speed of the 300-gram cart just after the collision? So here there are two unknown quantities. You know the initial velocity of the 340-gram air track. You know that the initial velocity of the 300-gram air track is zero because it was stationary. But after the collision, we do not know the velocities of either one of them. So that's what makes this problem tough. So I will do it in the proper way, which will be a lot of steps, but if it's a multiple choice question, you can simply substitute the answers and find out by trial and error. What am I trying to say? Let me explain. If it's an elastic collision, kinetic energy is conserved. So, in any collision, momentum is always conserved. But if it is an elastic collision, kinetic energy is also conserved. So we get two equations. So here's the diagram. The first object, second object is not moving. And after the collision, here they are. We do not know both their velocities. So I called it V1 prime and V2 prime. That's what I called it. V1 prime and V2 prime are the unknown velocities. So this is V1 and V2. So when you apply the conservation of momentum, we'll get an equation. So this is the conservation of momentum. M1V1 plus M2V2 is equal to M1V1 prime plus M2V2 prime. So when you substitute the numbers into that equation, we get 0.34 because 340 gram is 0.34 kilogram. And then this quantity becomes, of course, that quantity becomes zero. And then you have on the right side, excuse me, so you have on the right side that equation. And so the left side is just 0.34. And you end up with this equation. So let's call it equation number 1. So you see that there are two unknowns, and you cannot solve this equation on its own. Therefore, we apply the second condition, which is kinetic energy is conserved. And kinetic energy is what? 1/2 times mass times velocity squared. So, since kinetic energy is conserved, the total kinetic energy before collision, which is coming up now, should be equal to the total kinetic energy after collision. Right? And then substitute the numbers into that. When you substitute the values into that carefully, you get the second equation. This is going to be zero anyways because velocity is zero. And again, you're going to have two unknown quantities. And then try to simplify that. This gives 0.17, and on the right side you have two squares, V1 prime squared, making it even more tough. So we have to solve the two equations now. So what I did is, in place of V1 prime from here, as I'm showing now, I made V1 prime the subject here from this equation. I got the equation for V1 prime and substituted for V1 prime here, but it's a square, plus the second term. But when you open the square, you're going to get three terms. So what I did is I just divided this, took this out with a square, of course, and then simplified it. There's a lot of math that goes there. Because when you open this, you get three quantities. Because a minus b whole squared is a squared minus 2ab plus b squared. Sorry for that, but that's the math. And then when you do all that, you set up this equation carefully. There you go. So what happened here is the 0.17 can be cancelled off, you see, and so that's why you get that. Took this to the other side and I get the value of V2 prime. Once you get the value of V2 prime as 0.23, just plug it back into this equation. You will get the answer for V1 prime. Easier said than done. But so if it's a multiple choice question, what you got to do is you've already been provided the answers. So what you just got to do is just substitute into these equations and check if they balance out, for particular numbers, and then you will get the answer. So that's what I'm trying to say here. You just substitute the given numbers and check if both momentum and kinetic energy are conserved, which is what I'm trying to show here. If you just go with the multiple choice answers of 0.79 and 0.23, then you see that both momentum and kinetic energy are conserved within rounding errors. So if it's a multiple choice question, you just got to see if both momentum and kinetic energy are conserved, okay? All right, I think we go to the next one. Just two more questions to go. Here, it's about banking. At roads, at the curves, the outer side is a little raised than the inner side, which is called banking, and that provides the centripetal force. So here we got to calculate the banking angle for a car to negotiate a curve of radius 100 meters at 35 meters per second. So that's a fast moving car on a curve. So obviously the angle of banking needs to be high. It's a direct substitution into the formula. The angle of banking is given as tan theta is equal to v squared by rg. And just substitute. Velocity is 35 squared by radius is 100 times 9.8. Get 1.25, and that gives the angle as 51.34 degrees. That's a big angle of banking. So that's how you do problems on banking angle. Brings us to the last one. And here I wanted to do one question from gravitation. Gravitational force is a universal force which exists between any two objects in the universe, between the sun and the earth, between the earth and the moon. But here I just consider two objects of masses 10 kilograms and 5 kilograms at a distance of 10 meters from each other. And we got to find the gravitational force. Once again, it's a direct substitution of the formula for gravitation. So those are the objects separated by 10 meters. The formula for gravitation is here, g m1 m2 by r squared. So do not forget the square on the distance. Caps g is the universal gravitational constant, which will be given, multiplied with the masses, divided by the square of the distance, you get the answer. So I hope these 9 questions will be studied properly, understanding each one, because these are 9 questions on the exam. And then you have a bunch of conceptual questions, so which is almost going to give you a very good grade if you can really understand what's going on here. Thank you. Wish you all the best for all my physics students. Goodbye.